Oh, what a beautiful day. I just gotta turn off this amazing alarm clock. Oh, didn't see you there. Follow me. You might be wondering what this amazing clock is, huh? Let me just turn it off real quick and I'll tell you. This is the Es-sential clock, and this is our ES50 final video. Oh yeah. So one big thing with our alarm clock that we wanted to add to make sure it was feature rich was to make sure that you could change the time at which the alarm goes off. So all you got to do to do that, press this button. It indicates that you've now gone into time change mode, displaying all zeros. And now the only thing you have to do to change the time is use these two joysticks. There's a left and a right. The left changes hours, the right changes minutes. So you just move it and it's changing. As you can see, it's on a 24-hour time format. And we did that because it's a bit difficult to change in between AM and PM. And we figured 24 hours would just be easier. So if you want to change it to say 6:10, you just bring that down, 6, and then take this down as well, 10. And all you got to do now is just press this button, resets it back to the original time, and now you just wait until 6:10 and it'll go off. Bro, what's all the ruckus, man? Shut up, it's too early in the morning. Whatever. Anyways, back to the clock. Follow me. The machine you're seeing in front of you wasn't always as great as it is now. We did encounter some hiccups and some challenges and some trials and tribulations, as you do with all of life. So, the first challenge we really saw was the servos, right? The servos, they come pre-calibrated, right? We know that. Every EA constructor knows that. However, they weren't calibrated to our specific number of wheels, so we had to go into the Arduino code, a little trial and error, and sort of figure out the exact angle we wanted them to each turn, right? That was the first challenge. The second challenge came in the circuit design itself. Zoom in a little bit here. So, you see these joysticks and the servos? They all operate on the same sort of voltage. However, what would be difficult about that is if we do the 5 volts on one rail, each individual one would be pulling too much current, and at the end of the day, one component or the other wouldn't end up working. How did we solve that problem, you may be asking? We did solve that problem. What we did was we created 2 rails, one with 5 volts and one with 6 volts, and then we kind of plugged in the components individually. And then that means they were pulling in the current they needed without taking away current from the other components. That's how we solved that. The last challenge was this transistor right here, this little annoying transistor. We wanted the fans to go off right when the number wheels also gave off in order to maximize our alarm clock feature. We had to figure out how the transistor worked, but once we got that, it was smooth sailing from there. Cisco's gonna tell us a little bit about the code.
Whoa, bro, be careful. So now I'll just be talking about the code a little bit. Here's the final file. So this is the final code file, and we use 2 libraries here, servos and RTC, real-time clock. Here are these calibration angles that we were talking about. All the servos have different ones, and we just needed to guess and check to find them. Going down to setup, here you just attach a bunch of pins to everything, get real-time clock to begin and set the initial time, make sure the fan is off, and calibrate the joysticks. In loop, the first thing it checks is whether or not the alarm time is the current time, so that it can then call alarm match. We check if it's above 24, so we could put it back down, do a bunch of intermediate calculations to find the actual angle we need on each servo, and then write them. And then finally check to see if the button is being pressed to call time change, which would change the alarm time. In alarm match, we calibrate the joysticks again just in case, turn the fan on, and go through a loop so that the servos can make a whole ton of noise. And the loop only stops if a certain amount of time goes by, or if the joysticks are each pressed down. Then we have time change to change the time, the alarm time, same sort of thing. Check the joysticks to see how much we need to change minutes and hours by, and display it on the servos using the same exact intermediate calculations. And then indicates by changing the servos again, and then we set the time at the bottom.
And so yeah, that was the code.
And that was our ES50 final project. Thanks for watching.
So Cisco, tell me about you said a dream of a clock?
Yeah, I woke up and there was 2